Hello, everyone, and welcome to this edition of the ThinkOnward webinar series. I'm your host, Clark Dever, and we're happy to have you. Uh, Before we get started, just a few things. If you have any questions, please use the Q&A button at the bottom of your screen, and I will be moderating for Ashkan. And he has invited questions throughout the presentation, so whenever something comes up, feel free to ask, and we will interject and get that solved for you. The next thing I wanted to mention is coming up next week, we have an excellent webinar on geothermal. And so we're probably going to be releasing some projects and maybe even some challenges over the next year related to geothermal. So this is a great way, if you don't have a background in it, to get some baseline understanding of how it works. With that said, let me introduce our panelist, Ashkan Hussainalu. Ashkan is the lead data scientist at ThinkOnward, where he leads efforts at the intersection of machine learning, artificial intelligence, and energy solutions. With extensive experience in system dynamics and control, he leverages modern AI techniques to address pressing challenges in renewables and sustainability. Ashkan work spans optimizing renewable energy integration, enhancing efficiency in smart grids, and developing innovation data-driven solutions for energy resilience. His background includes a PhD from MIT and a postdoctoral research at the MIT Laboratory for Information and Decision Systems. Ashkan is passionate about harnessing interdisciplinary approaches to create impactful, sustainable solutions in the energy sector. With that said, I'll pass it off.
Thank you so much, Clark. And hi, everyone. Thank you all for joining our webinar today. So today I'm going to talk to you about the top 5 tips that I believe will help you succeed in data science challenges. Here's the agenda for today's talk. I'll start off with a brief introduction to challenges on our platform, and then I'll talk about the 5 tips. And at the end, I'll close the webinar by showcasing some of the exemplary submissions in our recent challenges. So we have challenges and bounties so our data science competitions are mainly formed and launched as challenges and bounties. And under challenges, we have structured and unstructured challenges. And most of our challenges are structured challenges. And this is the workflow and pipeline for structured challenges. So you're handed a training data set. You train and build your model on this training data set. And you're also given a test data set. Once you have trained your model, you run it on the test data set to create a submission file. And then this submission file, once submitted to our platform, is compared to a private answer key. And based on that, your public leaderboard score is calculated. If it's high enough and good enough, you'll be selected and you'll be invited to send your full submission that includes all of the codes and the files to us. And once we have those files and the codes, we run it on a holdout data set. This is a data set that your model has never seen in the past. And then a holdout score will be calculated. And this in addition to some other criteria that we will have for that specific challenge, such as interpretability and documentation, they will combine and they will form your final leaderboard score. So this is the pipeline for structured challenges. As opposed to structured challenges, we have unstructured challenges. And the main difference between structured and unstructured challenges is that in unstructured challenges, we do not have a single metric, a performance metric. And because of that, there will be no public leaderboard score. So you'll be handed a training data set, you'll build your model, and then you'll send all of your submission files to us, and we will evaluate your submission based on the criteria that is specific to that challenge. That usually includes exploratory data analysis, interpretability, documentations, and maybe some other criteria. And based on that, your final leaderboard score will be calculated. And this is, for example, one unstructured challenge that we launched earlier this year, Power Patterns. It was about clustering buildings based on their load profiles and then designing demand response programs for different clusters. In addition to challenges, we have also bounties. I would like to, I look at bounties as mini unstructured challenges. They're much smaller in scope and complexity, and we usually use them for things like web scraping and collecting data sets and developing dashboards and things like that. So I'm actually curious to see how many of you in the past have participated in our challenges or bounties. And I would like to ask, Clark, to pull up the first poll. I would appreciate if you can just participate in this. Take a few seconds. I want to say that the main reason I talked about the pipeline and workflow of our challenges and bounties is that I feel like that will help you better understand the tips that we're gonna talk in a minute.
So it looks like we have about 4 people who have participated before, and we've got about 8 folks who have responded who haven't. So interesting, a little closer to 50-50. It's waffling back and forth, but mixed audience.
Nice. So it's good that I talked about the pipeline. Cool. So let's start with the first tip, crafting a winning submission plan. So always start with a plan. And before diving in and jumping into coding, there are 3 main elements that define a good plan. The first one is understanding the problem. So please read the challenge descriptions thoroughly and identify the objectives and constraints. These objectives could be things like, depending on the challenge, it could be the performance metric that you optimize your model for example, a root mean square error in a forecasting problem, or a mean intersection over union for a semantic segmentation task. Also, it could include other things like interpretability, documentation. Also understand the constraints of the challenge, things like the data sets you are allowed to use, or the libraries, or the time constraints on the inference time of your model. So you can find all of these by reading the challenge descriptions thoroughly. The next one is, once you have a good understanding of the problem, is setting milestones. Usually the task and the challenge is a complex one. So break it down into smaller, manageable steps and chunks. And set deadlines for each phase. And these phases usually include things like pre-processing, data cleaning, model selection, hyperparameter tuning, exploratory data analysis. So break it down to these pieces and then set deadlines for them. So once you do that, the next element of a good plan is resource management. So assess the resources that you will need to execute these mini tasks. It could include computational resources, or additional libraries and tools that you need, or even external data sets if you think that would be needed. So one of the things, I wanted also to mention that, so one of these constraints is computational data, computational resources, right? For example, if you're working with on a image segmentation task, you probably need a lot of GPU resources. So upfront, assess these requirements, and if you don't have access to fancy GPU resources, maybe you can use some of the pre-trained models out there. And speaking of these pre-trained models, we recently launched a GFM model, Geophysical Foundation model, on our Hugging Face. I highly recommend you go out there on our company page on Hugging Face and look it up. I'm sure you'll find it handy in our upcoming challenges about geophysics. So we talked about the elements that would define a good plan. So let me talk a little bit about main components of a strong submission plan. The first one I already talked about, defining clear objectives. So what are you aiming to achieve? So these objectives, as we talked about, I want to highlight it, and I brought it up here again because it's very important, and it's not always easy to find all those objectives. So when we talk about objectives, we usually think about one performance metric to optimize for, like um, a mean intersection over union or precision or reference score, but it's not always that metric. It could be other things like documentation, interpretability, and many other things, more indirect objectives. So have a holistic view of these objectives from the beginning till the end. The other one is prioritizing your tasks. So once you set your milestones and break the task into smaller mini tasks, make sure that you prioritize them. For example, if you have a messy data set with many missing values, maybe prioritize pre-processing and feature engineering. Alternatively, if you have a very high quality data set, maybe you should put the focus on uh, streamlining the model and optimizing your model, a high performant model. The next one is adopting an iterative development approach. So plan for multiple iterations and improvements. And what I always suggest is starting with a very simple model and then build upon that and improve upon that. The next one is buffer time. So always allow some extra time for unexpected challenges that you may face, especially towards the end of the challenge. Sometimes also towards the end, you may have new insights to the problem and you want to go back and adjust your model and retrain the model. So by allowing some extra time for yourself, you'll be able to do that. And also documentation strategy. Have a upfront a documentation a strategy for yourself from the beginning to the end. This is very important because we also, I'll talk about this again in a few minutes, but part of your final leaderboard score, if you're invited to submit your final submission, part of your score is documentation. So have a plan to do the documentation. And there are many different tools out there. The basic and I think the easiest, the simplest, and one of the most effective ones is using a Jupyter notebook. It's very easy to document your findings, but you can also use other more fancy tools like experiment tracking software such as MLflow, DVC, or some other ones, but have upfront and a strategy for documentation. It's easy to leave documentation to the end because we always think like we remember everything that we do, but I think we all had that experience that we code up something and then 3 days later we get back and we have no idea what we have done. So please have a documentation strategy and do it from the beginning to the end. So we talked a lot about following the instructions and reading the instructions and challenge descriptions thoroughly. So let me tell you a little bit about some of the common mistakes that stem from not doing that. Some of these may look obvious or silly to you, but believe it or not, we have encountered these mistakes in many of our submissions. Incorrect submission formats, missing required files or codes, using unsupported software versions, specifically Python versions, using incompatible libraries. We always ask people to include a text requirements.txt file that lists all the libraries with their versions, but sometimes the libraries out there in that text file are incompatible and conflicting. Another mistake people do is using hard coding, especially when it comes to data path. And it impacts both you and us. If you have an incorrect submission format, when you want to submit it on the platform, there'll be an error processing your submission. So there'll be no score for your public leaderboard. If that happens in the final evaluation, after you submitting all your codes and submission to us, there could be delays in the evaluations, and it could potentially result in your disqualification. And we may, unfortunately, have to discard your submission. But the good news is there is an easy solution to that. Read instructions carefully, please. Use provided templates and sample submissions. We always provide a starter notebook with sample submissions and also functions to generate a sample submission. So make use of it. Have a checklist before submission. List all the libraries and dependencies that you have used with their versions and include them in a requirements.txt file and test it in a clean environment before you submit. And if you still have questions, you can post those questions in our discussion forum. Once you sign up for for a specific challenge, on the portal on our website, there will be a link you can access the discussion forum, and that's under the discussion tab in your portal. So tip number 2, conducting thorough data exploration. I think data exploration is always necessary because it helps you uncover nuanced patterns and insights that would eventually guide pre-processing and model development in your pipeline. So there are many techniques out there. Some techniques are some basic techniques that many of you might be familiar with, things like statistical summaries, visualizations, and we usually use them to identify patterns and anomalies, right? There are so many popular Python libraries and tools out there like Pandas, NumPy, Matplotlib, Seaborn, scikit-learn that are very easy to use with a lot of good documentations. There are also some more advanced techniques. Here I've listed 3 of them that are specifically useful for time series analysis and in geophysics. Autocorrelation and cross-correlation are very powerful tools for time series analysis. Power spectral density and wavelet transforms, very useful for geophysics-related challenges. And here are a list of a little bit more advanced Python libraries that you could use for these. TS-Fresh and CATS are very powerful for time series analysis and automatic feature engineering. SciPy is great for many things, including calculating power spectral densities, pi wavelets for wavelet transforms. And the last 3, Pandas profiling, SweetViz, and AutoViz, are libraries that you could use for automatic EDA, exploratory data analysis, and generating automatically reports for them. So let's talk a little bit about best practices for data exploration. One of the basic ones is handling missing data. So in real world, almost all of the data sets we have are not very clean. There are a lot of missing data in those data sets, and there are many different techniques that you can handle them. I have listed here some imputation techniques, from basic ones to a little bit more advanced ones that you can use for handling missing data. The second one is feature engineering. Feature engineering is probably one of the most important ones in data exploration that would also help your model training down the road. There are 2 main categories for them: knowledge-based feature engineering and automatic feature extraction using deep learning. The first one is based on leveraging your domain knowledge. But the downside for the automatic feature extraction is that when you combine it with your machine learning pipeline, it makes it usually very data hungry. And the problem with that is that in applied science applications, usually data is quite scarce because it's not easy to collect data. It's time intensive and very costly. The other thing is data transformation. Probably the most basic one that most of you are familiar with is normalization, scaling, and encoding. That will help your model learn much faster and more robustly with respect to the input data. But also I've listed 2 other data transformations here: frequency domain transformation and data augmentation for images and computer vision, specifically because they are very powerful tools for your pipeline in time series analysis and geophysics. And also, again, document your findings. This is very important, not just because it will help you understand what you do from the beginning till the end, but also it's part of the evaluation process for us. So your score eventually, in part, depends on how good your documentation is. You could use Jupyter Notebook. This is, in fact, the way that we will see your documentation, at least the majority of your documentation. But also, as I mentioned earlier, you could use other advanced tools like experiment tracking tools, weights and biases, MLflow, DVC, whatever that you feel more comfortable with. Tip number 3, streamlining model selection process. So my recommendation is always start with a baseline simple model. Start with a linear model. Linear model with some good feature engineering, can sometimes outperform very complicated and complex deep learning models. So start with something and start with linear. You can always, if you adopt, as we discussed earlier, if you adopt an iterative development approach, you can always come back and build upon that and improve upon your model. Let's start with something simple. And by the way, not always, we usually provide a baseline model in our starter notebook. So that will be a good start for you. So start with that and then build upon that. Evaluate multiple models and algorithms. Different models are better for different data structures and problems. And it's not always easy to know from the beginning which model is best for the task at hand. So try different models and see which one works best and pick that one, or maybe pick an ensemble of models. Cross-validation is another very important part of model selection and model training. It will help you assess the performance of your model more consistently, and also it helps your model to generalize better and avoid overfitting. This is particularly important for the challenges that we launch, because we always have a holdout data set, and if you're invited to send your submissions to us, we will evaluate that on the holdout data set. So the more generalizable your model is, the higher your score will be on the holdout data set. So don't overlook cross-validation. There are many methodologies you can use. K-fold cross-validation is one of the most popular one. The other one is hyperparameter tuning, that is also oftentimes overlooked, but it's very powerful. There are two main methods people usually use: grid search and Bayesian optimization, that explores the parameters of your model more efficiently compared to grid search. And the other thing to consider for streamlining your model selection is computational efficiency. There is almost always a trade-off between the computational cost for your model training and its accuracy or lack thereof. And the more complex your model is, it will require more computational resources, but most likely it will be more accurate. But sometimes you're constrained by the training time or the resources available to you. So you have to balance between these two. And it will bring me to my first point, to start with a simple model. You don't always need a very complicated model. So start with something simple. It's not good enough, then you can iteratively build upon that and improve upon that and make it more complicated and complex. So what are some of the tools that you could use for model selection? There are plenty of them out there. There's so many auto ML tools and libraries out there, like AutoKeras, Auto Scikit-learn, H2O, that will help you automate model selection, feature engineering, and hyperparameter tuning. Make use of them. If you're looking at a small class of models and you just want to do hyperparameter tuning, there are two very powerful and popular libraries, Python libraries out there for hyperparameter tuning, Optuna and HyperOpt. The first one uses Bayesian optimization, and the second one is based mainly on a tree-based search algorithm. The third one that I think is the easiest one to use is large language models. It's very easy. It's free. There's so many platforms out there like ChatGPT, Copilot, Gemini, you name it, Llama. So use them. Use them for not only for model selection and algorithm recommendations. You could use them for coding, for coding functions or snippets of codes, even for optimizing your code. You could use it for almost everything that I mentioned up until now, and you could do it for free, and no one holds you back from doing it. So I personally use it, so I highly recommend using it. It's very easy. And I'm actually curious how many of you have used or are using LLMs in any capacity in your work. So, yes, thank you. So if you take a few seconds participating in this poll, I appreciate that.
Oh, got some mixed results out of the gate. About 30% of the people say they use it for coding and automation or brainstorming and idea generation. And then the other 30% are split between data analysis and charting and graphing generation. And some folks haven't used LLMs at all for their work. So I encourage you all to give it a try.
Yes, please do it. And yes, I see the results now. Yes, because it could really save you a lot of time and effort, and it can help you learn. And I can't emphasize it enough how much it could be beneficial to you. And because of that, I have another slide on that. I highly recommend using it from beginning to the end. And there are some ways here I'll share with you that you could use LLMs for. Data exploration. You could ask LLMs to generate code snippets for you for different uh, different tasks in data exploration. You could use it for model selection guidance, uh, and ask for suggestions on what algorithms to try. Especially if you don't know anything about a domain knowledge and you don't know where to start, you could simply ask ChatGPT to suggest, for example, a suitable model for time series forecasting of energy consumption data. If you have no idea what algorithms out there in time series analysis or in energy domain. It could help you greatly with your coding. You can ask any of these LLMs to help you write functions, classes, fix the bugs in your code or even optimize your code. And documentation. And this is probably the easiest way you could use it. Sometimes we get submissions that are really good, but they have very poor documentation. You could simply copy paste your code uh, in ChatGPT and ask ChatGPT to write a thorough uh, docstring, for example, or comments for your code. So please make use of that. But in doing that, please keep in mind that if you use it for coding, always review and understand the generated code. And also make sure that you're compliant with the rules on AI assistance. As far as I know, and as of now, we have no rules against using AI on our platform. So please make use of it before it changes, if it changes. So tip number 4, I think we all have been there. And at some point in our career, we have experienced burnout. It sucks. I know it usually shows in the form of fatigue or decreased motivation or frustration, but there are ways to avoid it. One of the best ways is having a good time management. Coming back to our first few slides, set realistic goals, have a plan, set milestones and deadlines. This will greatly help you in maintaining a steady pace so that you don't rush as you get closer to the deadlines. Because of that, it prevents feeling overwhelmed and the burnout. Take regular breaks. Take short breaks in your daily work. There are many techniques. The most popular one is probably the Pomodoro technique, but also take longer breaks if you need. If you feel like you're overwhelmed in the competition, take a break for a week or two. These competitions usually run for 2-3 months. So I'm sure that you can afford taking a few weeks of break. Automate repetitive tasks. We already talked about some tools out there that you could use for different phases of your competition tasks. So make use of them. LLMs or AutoML, like whatever you can use for those tasks, make use of it. Embrace imperfection. This is something I personally resonate with, and probably many other perfectionists out there. Striving for perfection always leads to unnecessary stress. So focus on delivering a functional solution rather than a perfect one. So many people from the beginning look for the best or close to best model from the beginning. Unfortunately, that's not the optimal approach, and it brings me back to what we discussed about adopting an iterative development approach. So start with something basic first, and you always have the option to come back and build upon that. It doesn't have to be optimal or perfect from the beginning. And at the end, it's not going to be perfect anyways. As long as it's functional and it serves a purpose and it does the job, that will be good enough. Stay organized. Keep your code organized and well documented. Again, coming back to documentation and strategies, do it from the beginning to the end. Don't leave it to the end. It will make you frustrated. Use version control systems like Git because it can make it easier to collaborate with others. If down the road you decide to team up with someone and work on the competition as a team, it will make it much easier. And always working as a team will help because it will lighten the burden of the competition and it will help prevent the burnout. Practice self-care. It's very well documented. Physical well-being significantly impacts your mental health and resilience. So please get enough sleep, eat healthy, and exercise regularly. If you can't go to gym or exercise, take a 15-minute walk every day, and you'll be pleasantly surprised how it impacts your mental health. And seek support and collaborate. As I just said, working as a team will help you delegate tasks and lighten the burden of the competition, and because of that, it will help you avoid the burnout. But also, I believe this is particularly important for our challenges or any competition that is in applied sciences, because there are two main elements in data science challenges and applied sciences. One is the machine learning and data science part, and the other one is the domain knowledge. And it's very hard to be the master of both. So if you team up with someone, if you work in a team that some people are great with the machine learning part and some people have very great domain knowledge, you would make a perfect team and it will probably result in very good submissions. And finally, tip number 5, submitting a standout final entry. There are 3 main components to this: documentation, code quality, and reproducibility. So let's start with documentation. Please include a README file that provides the overview of your approach, setup instructions, and tells us how to run the code. As I said, it's very easy to use. You don't need to write it yourself. Use LLMs to write the Docker strings if you're lazy to write the Docker strings on your own, or the comments. This way it will help us. You can easily explain the classes, functions, your code blocks. Markdown cells. Here in the mark, so we always ask you to submit a notebook, a Jupyter notebook, and this is where you orchestrate the whole pipeline of your approach. So this is where you explain what methodologies you have adopted and what your approach is. This is where you talk about the EDA's exploratory data analysis and all the findings in your pipeline. And these are 3 screenshots from actual submissions. So please include these at least: README files, Docker strings and comments, and markdown cells for documentation. And this is important not just for your own clarity, but also for a good submission, because we factor in documentation in your final score. Code quality is the second element in a standout final entry. And there are different elements that make a high quality code. One is readability. Write it such that it's easy to read and understand. Make sure that you follow best practices for namings, function namings, variables, and classes. Comments where necessary. Complexity. Make it as simple as possible. Avoid overly complex functions or logics. Break them down to simpler ones. It will also help you. Not only it helps us to understand it more easily, but also it will help you to debug your code much more easily. And this is probably even more important to us than the previous two, maintainability and modularity. Please write your code in a modular form with functions and classes that can easily be extended or modified. And also, please separate different stages of your pipeline, such as data loading, pre-processing, training, inference, into distinct functions or modules. Because sometimes we just need to run your inference model. If it's written in a modular form, it's much easier for us to do that. If not, it will be a nightmare for us. And it could eventually affect your final score. Also once you have all these modules, use the main script that will be a Jupyter notebook to orchestrate all of these workflows. And here is almost a perfect example of one of our submissions. This is the file and directory tree for one of the submissions in one of our recent competitions. You can see that there is a different module for inference, for pre-processing, for setup, for training. There's a README file. The model checkpoints were in this folder. The naming conventions are followed. So please try to adhere to these best practices. It will make your life and our lives much easier, and will probably result in a higher score for you at the end. Reproducibility. Reproducibility is crucial, because if we can't reproduce your results, unfortunately, we have to discard your submission, no matter how high your score was in the public leaderboard score. And one of the key parts to reproducibility is environment management. Document the computing environment, including the operating system, Python version, all the dependencies and libraries. Include the versions of all the libraries in a requirements.txt, not just the libraries, but the versions as well, and make sure that they're not conflicting. Model checkpoints. Save and include trained model checkpoints, but also tell us how we can save, load, and use them. You can put them in the README file or in the Jupyter notebook. Dynamic path, and this is also something that is very important, and it will make our lives much easier when we are evaluating if you do not hard code the path. Sometimes people hard code the path, especially the data path. This is an example of a path hard coding, but instead use relative path. This is an example of a relative path relative to the working directory. And here's an example of how we can use it as set the path as a variable, or pass it as an argument to a function. And also use consistent random seeds to make your results reproducible. Very easy to do that in almost all of the libraries. These are some examples how to fix the random seed in NumPy, TensorFlow, and Torch. So final checklist before submission. So once you have done all of these, once you think like you are ready to submit your zip file that includes all of your files and codes, have a final checklist. Review submission guidelines. Again, go back and make sure you understand all the guidelines and you've followed all the guidelines, things like avoiding using private data sets or prohibited libraries and frameworks, things like make sure that if there is a constraint on the time that your inference model, make sure that you adhere to that and it runs within that time frame. Test your code. This is very important. So once you're done, please make a clear environment and then install all the packages and libraries that you have included in the requirements.txt and make sure that you can run and test your submission and your code in that new environment. This will essentially mimic how we would evaluate your submission. So if you can't do it on your own, on your end, we probably wouldn't be able to do it on our end. So please do that. And validate output formats. So we always, as I mentioned, we always provide sample submissions and also in the starter notebook, some functions that would generate a sample submission. So make use of that to make sure that the output of your code has the correct format. And again, complete documentations. Use whatever methodologies you want to use or whatever tool you want to use, but have a complete documentation. Include README files, Docker strings for your functions and classes, comments, markdown explanations in the starter notebook, and so on and so forth. And finally, double check all the files and make sure that you include all the necessary files like the license, the notebook requirements.txt, model checkpoints, and also make sure that you exclude unnecessary files, specifically train and test dataset. Believe it or not, we do not randomly delete our dataset. So if we have provided the test and train dataset to you in the beginning, we still have them. So please don't send back the train and test dataset to us. So these were all the tips that I believe would help you in submitting a great submission for our challenges. But let me showcase a few submissions now. Some of the submissions, good submissions in our recent competitions. So let me go on. So here is our company page at GitHub, and we've uploaded some of the winner solutions of different challenges there. So if you go there, so on challenges, we have different folders for different application domains. And under energy analysis, we had 4 challenges this year and towards the end of last year. And here, there are 2 of them I wanted to showcase to you. So this is one of the submissions for the unstructured challenge that in the beginning of the presentation, I told you a little bit about. And this challenge was on clustering load profiles, clustering building based on their load profiles, and then designing a demand response program for them. So here is an example of a very nicely written and well-documented notebook. There are a lot of, there's a table of contents, there are a lot of extensive EDA, exploratory data analysis with plenty of explanations for each step, a lot of enhanced feature engineering, very nice plots. It's very well written. So it really feels like reading through a research paper, a very well written research paper. So I highly recommend and encourage you to go out there and check yourself different winner submissions on our GitHub page. Here's another one that we recently closed and evaluated, Building Instinct. And this is one of the submissions. Here is, you can see there's a license, there are 2 README files, there are different modules for different parts of the pipeline, inference, training. So here this README file explains how the environment could be set up. It explains the files and the folder structure. Also, there's another README file that explains in detail the approach that this person took, different steps like downloading external data sets, extracting features, and training, and then inference. So I highly recommend you check it for yourself. I believe that you will learn a thing or two. I personally have learned a lot looking at these great submissions. So with that, I will stop sharing and I'll thank you so much for attending the webinar. I'll take any questions if there are any questions.
Yeah, no questions so far, but we'll give everyone a couple minutes to answer. Ashkan, excellent job. Very informative. As someone who hasn't competed in a data science challenge, it was very interesting to me, like how complex it is. And so I think you did a great job of breaking down the steps and giving me the keywords to go do more research, learn about all those different libraries and techniques you mentioned. What, if I can ask, how did you get started in data science?
Oh, mine is probably not similar to many other people. So I was in academia for a long time. And then the way I got it started was it was 2017, 18 when reinforcement learning was coming to surface with AlphaGo and stuff. So uh, in control, system dynamics and controls and system IDs. And I saw the connection between reinforcement learning and control. And that's how I got interested in the field. So I started with reinforcement learning and then different parts of uh, machine learning. And and then we worked on, and then pandemic started. And then we worked on how we can use sensory data in buildings to uh, to prevent the spread of COVID pathogens. What are data-driven approaches that we can do? Again, reinforcement learning. So that's how I got started with machine learning. And yes.
Thank you. Uh, so Ghislaine has a pretty specific question. So I'm going to throw it out at you, and you can tell me if you have an answer. It says, can you explain how you model on AWS SageMaker G5 12x large instances?
What do you mean by modeling?
I don't know.
Oh, okay. I think where the question is coming from. I think that's the instance we use for our evaluation, and then we say that your model needs to run within 24 hours, otherwise it would discard. So I think the question is, we don't have that instance. How can we know that it runs, in that time frame? There is, unfortunately, there is no clear answer to that. I know many of your local machine may not be as powerful as the instance that we use. Just do some ballpark. Like if you think it's half as powerful, then it should run within 48 hours. But I can tell you that we never had an issue with that in our submissions. 24 hours on that instance is plenty of time for inference. So if your model does not run within 24 hours on that instance, there is something seriously wrong with 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 the code, with your model. So don't worry about not being able for your inference model to run within 24 hours on that instance. I mean, yes, make sure that it runs fast, but it usually doesn't take that long. We never had that issue. Almost, I don't recall if we ever had any issue on that.
Thank you for providing some clarity to that and good synthesis of that question because I was like, I don't know where this is coming from, but I'm glad you did. Wonderful. So another question that has come to my mind, right? Like, obviously, you've run many competitions at this point. Do you participate? Have you participated in the past? Not in ours. There's rules against that, but on other data science challenges, have you had any experience doing that? And what did that feel like?
To tell you the truth, no, I've never, I've never participated in any of these. I mean, I've looked into them. I think in the very beginning I did a few on Kaggle, but I didn't submit anything. Uh,
Hmm.
I just did it too. So it's a great question because the way I looked at it was learning when I first started. So I think that's a great way to learn things, just doing not just for the prize. I mean, yes, if you win a prize, a prize money for that, wonderful. Uh, but if you don't, you will walk out with having something learned. I think that for me that was the most important part. Learning something out of these challenges, and especially for us, like for challenges on our platform, they all come from actual clients, so they're real world. Maybe we have tweaked them a little bit because we were not allowed to give all the details, but they stem from real world uh, applications and problems. So tackling them will help you understand the intricacies of real world problems and will make you ready to go out there and do some real uh, challenges in your work.
It's a good point. I also believe in learning by building things. I think you can read a lot, but you never really grok, and understand the information until you've utilized it in a practical sense. I'd like to plug if you go to the challenges section of the ThinkOnward platform, we have what we call Sandbox, and in the Sandbox we have challenges that we've already run, and those are, so you have access to the data, you can see results and examples, and it's a great way to learn as well from some kind of past performance that we've done. But just wanted to second your belief set because I really do think that as a builder, that's the best way to learn and gain experience. And I think that's one of the great things about these data science challenges is, we're working on ways to allow you to get recognition on your LinkedIn profile or in your social network as a participant, as a finalist, and really kind of demonstrate the work that you've put in to the projects.
Of course. And you brought up a very great point about learning by doing things, Clark. It's very actually well proven and studied that there's a correlation between high retention and learning things by doing. Sometimes you read something and you're like, oh, I know how to work with this library, Python library, so I don't need to do it. But then 2 days later, you can't remember syntax was or how it worked. But if you do it once, it will stick in your mind and you will remember it for a longer time.
Yeah, and to build on that, I think you spoke a lot about developing iteratively, and that could mean within a project or it can mean over a series of projects. One of the things that, as the host of these webinars, every time we do a webinar, we run an experiment, right? Like we don't necessarily say, hey, this is an experiment, but we're always trying to iteratively make the experience better. And so I'm going to use that as a segue as well. At the conclusion of this webinar, when you sign out, there'll be a brief survey. It's 4 questions. We look at that, we take that into consideration, and those are some of the ways that we generate these experiences and experiments is with your feedback. So please do that. Um, we don't have any further questions, so I want to, allow people to have this. Oh, wait, we have one more. Ghislaine asks, do you have any tips on using Google Colab? Snuck it in under the wire.
Yes, I think we have. I haven't used I mean, I used it a few years ago, once or twice. I think you have compute resources. So the good things with Google Colab is that you have compute resources out there. Uh, I think that's the main benefits when I used to work with it. But I don't have much experience. But I believe we we have some. I wish Jesse was here to answer that because I remember he did some Google Colab work in one of our challenges. But yeah, I don't have much experience with that. But yes,
I'm a
whatever.
big fan of collab. I think it's a great way if you're just starting out, it eliminates the need to like set up your Python environment and stuff. You just start with a Jupyter notebook. You can open other people's projects in it, and it's a good way to experiment. And they give you like it's a fairly substantial free tier, right? You have to be doing a decent amount of compute before you run into the paid tier. So especially for a lot of our international contestants, where like the U.S. dollar amounts can be kind of painful, that's a great resource to check out and utilize.
I think AWS SageMaker also has free tier, right?
Yeah.
You can
Yep.
use it.
Yeah.
And there are some packages already installed for you, like Python packages that you don't need to set up everything from scratch.
Yeah. Ashkan, there's two questions real quick. Do you know if we should expect another tabular competition from one anonymous attendee? And then the other question we had is, could we get a PDF of the slides?
I think the PDF of slides, it depends on the rules that we have. I think you know it better, so I will leave it to you. I personally fine
Yeah, I
with
think
it.
this is fine. We're good. We should be able to save it, and we'll put it. We're going to work on taking this specific presentation and slides and making them available in the challenges section of the website because I think it's valuable for onboarding people. So I'll try and get a link to the PDF of the slides, and that'll go out in email to attendees and people who were absent.
Sure. And with regard to the first question, I think by tabular they meant time series analysis because we had like three or four of them this year. We we probably have, but maybe not this year, maybe early next year. But we, as of now, I can't promise that we will have any this year, but we may. Just keep checking our website for new challenges and bounties. And I think that's the best way to get notified of what's going to come next.
Yes, exactly. ThinkOnward.com. You can register, sign up. Earlier, I put the challenges specific section of the website in the chat. So we look forward to having you join us and compete in further challenges. Thank you for giving us your time today. Thank you, Ashkam, for the excellent presentation. Very thorough. Sign up for the geothermal webinar if you're interested. I think it'll be very informative like this one. I'm excited. I've never done anything with geothermal. Can't wait to learn from our Liz Roller, who's our expert in the field. So that'll be fun next week. Thank you all for attending, and we'll talk to you soon.
Thank you, everyone.